Good afternoon, everyone. Thank you for joining us today at our Enablement series. This session today is co-organized between GeoWorks from Singapore Land Authority as well as National Supercomputing Center. Okay, let's give us some time for more attendees to join us. So we'll start very shortly. Okay, before we begin, I'd just like to run through some housekeeping slides. Okay, everybody, all the participants, when you join, be kept on mute by default. The session will be recorded, so a copy of the webinar will be made available after the session. And also, if we welcome everyone to use the chat session to introduce yourself, and you can network amongst your fellow colleagues from all the various government agencies. Okay, and also please use the Q&A function to put in all your questions that you may have for all the speakers. We will address all the questions towards the end of the session. Okay, this is an overview of the agenda that we have today. So very shortly after this, I will be introducing Li Yang, Mr. Lim Di Yang, who is the Deputy Director from Geospatial and Data Singapore Land Authority, to give his welcome remarks. Okay, right now we have about 50 participants already. Perhaps Li Yang, maybe without further delay, you would like to share with us your welcome remarks for the session?
Hi, certainly. And good afternoon, everyone. I'm Li Yang, the Deputy Director of the Geospatial and Data Division of SLA. I'm very happy to welcome all of you to this webinar co-organized by GeoWorks and our Geo partner, the National Supercomputing Center Singapore. And it's really wonderful to be here in the company of many experts and diverse organizations and participants we have here today. Now, for those who are new to us, GeoWorks is a Geospatial Industry Center set up by SLA, and our aim is to develop a vibrant geospatial ecosystem in Singapore, and to bring together geospatial businesses, scale-ups, big companies, and government agencies to promote business growth, to drive innovation, as well as to foster a very well-connected geospatial community. And I find today's webinar topic, reimagining the future of smart cities with high performance computing, highly relevant to the issues that we're facing as a city nation today. Rapid urbanization and digitalization are megatrends impacting all of us, changing the way we manage cities, and perhaps really giving us less margins of error in how we plan and operate. And we need to do more micro-planning, more optimization, and we'll hear more about that today. Working with and making sense of large streams of data, creating models and simulations, etc. Hence, I think the demand for high computing power will only continue to increase, and it will be a very important area going forward. Perhaps I also like to take this opportunity to announce that GeoWorks, in collaboration with NSCC, will be launching the Geospatial Innovation Challenge in September this year, during our Singapore Geospatial Festival. Now, the challenge aims to deliver transformational solutions to smarter cities, and top entries would stand to win resources to develop your POCs. So do keep a lookout for this challenge and more details about it in the future. For now, I wish all of you a fruitful session, and do enjoy the webinar and the rest of the afternoon. Thank you, and over to you, please.
Thank you, Li Yang. Thank you for your welcome remarks. Right. All right. Now I'd like to introduce our next speaker, Mr. Bernard Tan, who is the Director of Strategic Planning and Business Development from National Supercomputing Center. He will give you an introduction of who we are, what we have, and also be sharing with you some case studies of and use case of high performance computing. So over to you, Bernard.
All right, thank you so much. A very good afternoon to everyone, and thank you so much for your time. We are actually very excited to bring to you this enablement session. This is actually one of our many outreach sessions that we have been doing with a lot of government agencies, from MES to all the IHLs, including industry leaders itself. The objective here is really how we will be showing how high performance computing, or also known as HPC, can be used to catalyze and accelerate innovation and impact the way we live, work, and socialize as well. Now, we also be sharing how you can actually leverage on NSCC, but having said that, it is also important to have the expertise. And in today's session, we have invited a panel of expert speakers, which I personally very, very keen to learn from all of them, to share their various innovation within the smart city ecosystem, which is made possible with the help of HPC. Our first speaker is actually Dr. Luo Jing. He's the principal scientist and the director for Fluid Dynamics Department itself and at IHPC under A-STAR. So Dr. Luo leads and focuses on various fluid-related problem and research, new technology development, and industry solution. Today, he will be sharing one of his key projects, large-scale urban environment modeling with HPC. So that is something that to really look out for. Our second speaker is Genevieve. She is the Assistant Director for Livable Cities at NMD and currently heading the Complexity Science team in CLC. She's interested to study how network modeling, spatial data analysis can be used as a scientific method to inform urban planning, strategies, and planning itself. So today, she'll be sharing her CLC network modeling project, which is a bottom-up approach to route optimization planning. And lastly, we have Song Yu, who is the executive data scientist from the design and planning lab at URA. So Song Yu is actually involved in mobility-related topics, where he harnesses insights, trends to analysis of data sets, such as public transport transaction records. In particular, he has started an initiative to crowdsource walking and cycling network data sets through the use of mobile application. He will be sharing how network analysis is applied in urban planning to ensure good accessibility to amenities for the public. Now, we have all these wonderful speakers, but before we jump into each one of them, allow me to set the stage why we are here today. COVID has done to many government and CEOs and CTOs that's found hard to do, and that is to accelerate digitalization. Government officials and business executives all have a vital role to play in guiding their country and organization to function effectively through this COVID crisis. The scale and impact it poses is a real threat to our nation and to all business itself. It is also significant impacting the way in every aspect of the way of our life, from nation competitiveness to an enterprise viability, economies of operation and financial system, to social and everyday life. It is reshaping the way we know. So the speed and the need to digitize, transform a business, a nation, has gathered greater momentum and urgency. So it is vital for all our government agencies, local enterprises, IHL, to leverage on technologies such as supercomputers, as well as proven methodologies such as IEM Sim, to achieve innovation with agility and precision, as what Liang has earlier mentioned. Now, for this innovation to work, there's always what I call the Trinity. What is that concept and problem statement or the idea? The next one is the scientific talent that we need to have. And lastly, what is the high-tech infrastructure such as HPC and the software stack that's available? With these three Trinity combining together, this is where the cradle of innovation will be born. So digitalization has given birth to avalanche of data. So it is important to make purpose use of this data to power new innovation from AI, IoT, predictive analytics, optimization, robotics, security, simulation. Okay, therefore, to cater and to utilize this data effectively, do not downscale your problem. In the past, because of infrastructure constraint, we always do pilot sampling. Now with HPC, you do not need to do that anymore. You can able to crunch, analyze, compute, and deliver significant big data with the power of compute and GPU resources, as well as scientific knowledge to address and answer all these problem statements that you may have. Okay, so it is critical that data, it is through data that groundbreaking scientific discovery are made and game-changing innovation are fueled. So today we hope that with the introduction of this seminar, webinar, it is not going to be just one-off, it's going to be a series, and we hope to create the awareness as well as inspire all of you to start to explore and collaborate with us, partner with us on this innovation journey itself. Okay, so without further ado, do allow me to do a quick run through of who NSCC is and the resources now available that you, for all the SLA GeoWorks team members, colleagues, that you all can leverage on. Okay, so please allow me quickly to share this. Okay. Okay, I hope all of you can see my screen.
Yes, we can.
Okay, thank you. So NSCC is what we know as a national research infrastructure. Okay, we started off with 4 founding stakeholders from A*STAR, NUS, NTU, and SUTD. And we have actually expanded to multiple new stakeholders like NEA, TCOMs, SCC, SingHealth, NHS, as well as all the IHL. And we also have industry users such as Sabana Jurong and C Group, which is, you guys will be very familiar with Shopee and Garena itself. Now, NSCC is a national research infrastructure funded under NRF to provide computing resources. Okay, and so we are the horizontal enabling platform, national platform. It is a national resource platform for all government agencies, IHL, as well as research institute, including all industry itself. Now, having a supercomputer by itself is not, it's going to be useful if it's not well connected. I'm pleased to share with you all our supercomputers are all highly linked up locally as well as internationally under 100 GPS, which is one of the fastest network available in the world. NSCC is also the first national petascale facility itself. So as I mentioned, we are funded under NRF, under PMO office. More importantly is that we are managed and hosted by A*STAR itself. Okay, as you can see, this is our steering committee chaired by Mr. Peter Ho, which is also the chairman for UIA. And we have all the distinguished scientists and professors across Singapore, including internationally, like Professor Satoshi from Brigham, who manages Fugaku, the world's fastest supercomputer, as well as our colleague in the United States as well. Okay. Now, very important, our objective is to democratize access to supercomputing itself. The idea is to support R&D, attract industry collaboration, and overall enhance research capabilities in Singapore. Now, our current infrastructure is called Aspire 1. That was developed in 2016 with 1 petaflop system and 13 petabyte storage. We also have a AI platform, and as well as a climate system called Copen that is utilized and shared with an NEA. Because of the increasing demand for computing power as well as GPU for simulation in AI, we have we just announced on 27th April to build a second supercomputer at NUS I4, which is 10 times bigger and faster on that basis. And with this supercomputer coming online by end of this year, it will be readily available to support all your computing needs itself. Okay. Now, this supercomputer, as one thing that I just want to highlight, especially with the explosion of data, and as well as a huge increase in demand for GPU for things such as AI, machine learning. Point number 5, we have now acquired 352 NVIDIA A100 GPUs to address any kind of heavy workload for AI and machine learning. So please feel free to leverage on our infrastructure that is a shared infrastructure nationally. More important, as I mentioned earlier, we have expanded network infrastructure with multiple 100 GPS. So no matter where you are in Singapore or even collaboration with international collaborators, we are all well connected to share data and create innovation seamlessly with very, very low latency itself. So this is a very good snapshot of how we are connected on the top left-hand corner, the map, where we are all linked with InfiniBand connectivity up to 100 GPS, and globally on the right as well. And this is made possible in partnership with Single RAN. Okay, and we can connect to US, Japan, Australia, Hong Kong, Europe, no problem. Okay. Now, very important also is that we are embarking on several key strategic initiatives. One is to upgrade our national platform resources. As you can see, as we are going to launch our Aspire 2 with 10 times the capability. We are also looking to launch HPC Cloud with the hyperscalers that will make available very good easy user-friendly interface. And we will continue to invest in our global HPC. But very important is that we are also working with supercomputers around, supercomputing centers around the world to create what we call a HPC bank to centralize and make available HPC resources. Now, these are some of the very important projects that has been done through supercomputers. So no matter what is your data sets, whether how big it is, this is where HPC can help you a lot. Okay, so do not hesitate to reach out to us if you have any important projects you're working on and you are taking like a few weeks just to do one simulation. It probably would be done in a few hours or a day or two in the supercomputer environment. So that will help you to do multivariate simultaneous simulation as well, or optimization itself. Okay, now there are various interesting projects that have I think leveraged on supercomputers to achieve the outcome. One was to do with the droplet of dispersion to combat COVID-19. I'm not going to go into this, but just to showcase some of them. The other one is about discovery of new material, cooling of Singapore, together with the Virtual Singapore project itself, including the genomic sequencing of 10K Singapore. Now it's going to expand it to 100K in the shipping industry, and many more. So earlier, Li Yang has actually shared about the competition that we are going to embark on the Geospatial Innovation Challenge. That's something that's very exciting. We will be working with several parties as well as experts to also bring in mentorship to advise and mentor some of the project owners or PI, principal investigators, to help them achieve the desired outcome of their projects and accelerate their business outcome as well. So I think it's an exciting time. I think it's a great opportunity right now for us to be sharing with you, and we hope to be your partner in propelling you to greater heights in all your endeavor they're doing, and help Singapore as well as our industry to achieve greater innovation and outcome for the greater good. With that, I would like to end my time and pass it back to Angie.
Thank you, Bernard. Thanks for sharing. So Let me now, without further delay, invite Dr. Luo Jing as our next speaker to share his slide. So Dr. Luo Jing is a principal scientist and department and director of Fluid Dynamics department at the Institute of High Performance Computing, or A*STAR. Dr. Luo, over to you.
Thanks, Angie, and thanks everyone, and have a good afternoon to everyone. My name is Lu Jing, come from Fluid Dynamics department in IHPC A*STAR. In next about 15 minutes, I will give a very brief introduction about one of our projects and outcome. We call it the Integrated Environment Modeling Modular Simulation Tool. We call it IEM Sim. This project is a jointly developed and also prototyped together with HDB and A*STAR. So far the project has been completed, and also IEM Sim as a product has been launched and also can be used by users. Sorry, I put in the presentation mode. I would start from the environmental physics and how the people will use tools to make scientific evaluation about environmental impact. As we know, if we're talking about environment study, there are two different factors. One is coming from the environmental parameters, which include temperature, traffic noise, solar irradiance, shading, and wind flow, all these natural environment parameters. On the other side, we have so-called design parameters, include water bodies, green space, building mass, topology, as well as porosity. And if we really want to do an environment evaluation, all these two different categories of the parameters must interact in the multidisciplinary manner. At the moment, the people using different tools to identify or simulate different physics. For example, for the solar radiance, and they have a particular commercial software or community software, they can use it. And for wind flow, they also have a commercial software available, or traffic noise as well. However, as I mentioned, all these parameters in both design and also in the environmental parameter, they must be interlinked and interact together. That means it's a multi-physics interaction. However, at the moment, using the different individual package, it cannot achieve this interaction or coupling of physics, different physics. So this is where I think we face a lot of issues up to the designer and also to the urban planner. So they have to use different tools and embark on different commercial package without coupling and interaction about different physics. So this is where I think our project coming in. For this IEM project, what we really want to do is we create so-called fully coupled interactive physics into the one tool we call the Integrated Environment Modeler, which considered the wind, thermal, solar irradiance, and also traffic acoustics, noise interactively, and also the fully coupled. And also another part is we want to create a platform which is based on open source and also in-house developed code rather than on the commercial package. Because for commercial package, there are a lot of limitations and people cannot, first of all, cannot be easily customized. Second part is also very costly at the moment now. In particular, if you're talking about HPC application. Of course, for any software, in particular for environmental studies, a key issue, how do we calibrate and how we validate the model itself. So this is how I think for us, we created this framework, and also we want to using the digital urban so-called infrastructure or data available. That means we will leverage on any digital model available in urban design. And also we want to interfacing of our IEM tool with other planners, the digital platform. That means we create interface and to embed it or integrate IEM to other different package which user preferred. So these are overall concept. And at the moment, as this is how is IEM usually works. So first of all, we start from the key urban infrastructure or features we call the land usage data, include so-called building, and include greenery, including water body, and also other infrastructure. Second part, and we consider the solar heat gain and under these particular features, and then we can simulate the wind flow as well as air temperature, and also include traffic noise. So this is how is IEM works, and also the main functions so far. And as I mentioned, it's all achieved in one platform in the universal starting point as a urban digital data. So IEM Sim can be used as a digital twinning for the built environment. At the moment, we already demonstrate IEM has been integrated into the Virtual Singapore platform, which is shown in the left-hand side of the bottom. Basically, you can use Virtual Singapore platform to drive IEM to run the simulation, and also to visualize the result and the data in the Virtual Singapore platform. So that means you can activate the IEM Sim through Virtual Singapore platform to set up the case, set up the model, run the simulation, and also can get the data and visualize in the Virtual Singapore platform. So also, the IEM, we work together with the JTC and using the IEM to the Punggol digital district planning and development. This is a live project, and we are working on together with the JTC for PDD planning and development work. I think for this user interface, I go to next page. This is how IEM Sim looks like, and this is a simple, very simple universal interface, and the user can go to this part to set up the case, and they can select either solar irradiance model, or they want to do just airflow, wind, or they want to do the airflow and also plus temperature, thermal. And also they can do the noise alone, and also they can couple the wind condition or weather condition with the noise simulation. So everything will be shown in on the model setup will be in this simple platform. The people can monitor the so-called properties you set, and also the running progress status in this part, and also can visualize the result, intermediate result, as well as the final result, and do the post-processing into the same interface. So this is how it looks like. And in terms of validation of IEM Sim, we conducted quite different numbers of validation. This is the show for solar, for wind, temperature, and also for noise. We use the Punggol district, the Tangah New Town. We conducted one year round of the sensing data analysis, include solar, include airflow, include temperature, include noise level in the horizontal level, and also along the vertical level for the noise. So we calibrate our model and compare with the field ground truth measurement data. So some parameters we fine-tuned, and also some algorithm we modified. So that means we really can calibrate and validate the result using the whole 1 year cycle of the data. And also we conduct also the so-called scalability and the validation at different level, for the district level, for the small neighborhood level, and also the town level. So we calibrate and try to understand what the scalability and what can be the quantitative accuracy at different level. This just show in fact, for the Tangah New Town and using the IEM. This is a new town, this is a baseline design, and we conducted a what-if scenario, include the greenery and also the water body, and also we we get result and to see the solar gain and also wind flow, and also what's the wind corridor if under this current design. and also what's the temperature distribution, what's the noise level at different neighborhood. And also, as I mentioned, we do the what if scenario as well. We plant different trees in terms of density and also different tree species, and we can understand what could be the impact for the temperature and thermal comfort level. And at the same time, we also do very huge, large scale simulation, include whole Singapore with very high resolution. This is a 10-meter resolution and 3-dimensional result. And we using NSCC resources to conduct the work. This is for the city scale solar irradiance at a different time of the day. And another part, we conducted the whole island simulation of the wind flow simulation result. So this is the result, and we get at 10-meter resolution and in 3-dimensional manner. And this include almost all the buildings around I think 50,000, more than 50,000 buildings inside Singapore, big and small. So with a very high resolution study. This is the work we conducted about 2 years ago. At that time, we used 2,000 CPUs, 2,000 cores at NSCC. And at that time, we takes about 5 days to finish the result. After that, we have done 2 things. One is we do the furthermore optimization of the IEM, and also some of the algorithm in the backend algorithm we also changed, and also the element and the mesh number we optimized. So with all this effort, at the moment for the whole island simulation, we can achieve 2 to 3 times faster. That means if we using NSCC use 2,000 cores now, we can get the result in 1 to 2 days rather than 5 days. So this is how we do it, and using HPC. In terms of IEM Sim intermodal requirement, in most cases, I think we still need a HPC level or cluster facility. If we talking about a typical township scale simulation, normally it requires above 100 million element, and requires RAM memory about 512 gigabyte, and also at least 64 CPU. And we can, for this kind of typical township simulation, we can expect the whole run complete in about 1 hour. That means that during the 1 working days, and we can finish the simulation in the typical township. And in terms of input, we need STL geometry property as input for the IEM simulation. Of course, this STL geometry can be converted from other geophysics data set as well. So, but as input, and we need STL data format. In terms of IEM Sim Readiness, and as I mentioned, IEM Sim has been developed, validated, and also we conducted finished user acceptance test. And also IEM Sim has been verified for successful running on workstations in both IHPC side and as well as HDB side, and also running well on clusters and also HPC system at NSCC. So that means if you really want to use IEM Sim on the HPC at NSCC facility, is already tested and work well. And also IEM Sim operate on the Linux operating system as well as a Windows virtual machine. IEM Sim able to integrate with other platforms. So far, we already integrated with the Virtual Singapore platform as well as JTC's their own digital platform. And the last is IEM Sim as a product, and we have been successfully licensed to Vision. It's a local SME, and they will help us to do the distribution and further UI UX development, and also the technical support and the maintenance. So that's how we license and collaborate with the private industry to promote IEM Sim as a commercial package. And For the future, and in fact, it's ongoing research activity, built on top of the success of IEM, we also understand in terms of urban design and also in particular for the climate change impact, there are more and more interest and also physics, complex physics we need to consider. So for the current IEM2 project, we also will work together with HDB. We want to expand a few important physics features. For example, for the environmental factor, we want to include now in the humidity and also mean radiant temperature, as well as a thermal comfort index for that part. And the second part is we want to streamline with the meso scale and also micro scale urban weather condition. So that means there will be automatic link with the weather result and also the weather station measurement database. And the third part, we also need to consider the wind-driven rain. I think it's for many users. I think wind-driven rain, in particular in tropical areas like Singapore, create a lot of concerns. How to evaluate this wind-driven rain impact is also important part. So we will include that part. And also another part is building energy, either for HDB or for commercial usage. I think the building energy consumption and also efficiency create a lot of issues. So we want to build up the energy modeling into the IEM phase 2. Another part is the aircraft noise. This aircraft noise we're talking about not really of the civilian aircraft, but also mainly focus on the military aircraft, because in the Pango, Sengkang, and a few other towns, the residents raise a lot of concerns about noise part. So we want to first of all, we want to understand what's the noise signature and what's impact zones to different resident township or neighborhood. And then we consider what's the mitigation strategy for us to try to depress this aircraft noise. So also we want to further integrate IEM to other platforms as well. And also we also want to focus on advanced greenery modeling. For the greenery modeling, we will consider all the trees and the grass and all this part. We put some biological information or so-called aerodynamics features into this greenery model as well. Another part is important is we also want to include the land usage optimization. It's extremely useful for urban designer when they want to design different features and different building mass for different townships. So they want to try different scenarios. However, at the moment, if we want to do the simulation, we have to redo for everyone. So this is why we want to include a feature called land usage optimization, which can allow the user to demolish some buildings and add new buildings without rerunning the whole simulation, but rather than using the original background information and try to customize and modify the local simulation. So this is how we do the facilitate this land usage optimization into this IEM phase 2 project. I think with all this, and I'll stop my sharing here. And if any questions, I'm willing to answer later. Thanks everyone.
Thank you very much. Thank you, Dr. Luo, for your sharing.
Thanks.
Right, next up, I'd like to invite Genevieve to do her sharing. So Genevieve is the Assistant Director of Research from the Center of Livable City, CLC, from MND. Over to you, Genevieve. You can start sharing your slide now.
Okay, thank you, Angie. Hi, everyone. You guys can see my screen, right?
Yes.
Okay. Yes. Hi, everyone. Just to give you a short background on myself first. So I used to train as an architect, and then I moved on to urban planning, urban analytics, and I was pursuing a PhD in architectural spatial computation at UCL in London. Then COVID happened, and then I paused it and I came back to Singapore. So now I'm in the research team at the Center for Livable Cities. And I've been given this opportunity to use what I've learned in London, which is space and text street network modeling. And over the last few months, our team has explored using this tool as a way to go about urban planning in Singapore, and hopefully using it as a design decision tool for future planning in Singapore. So today I'll share with you some of the demos that we have done. And also I would touch on some of the real projects that we are doing also, but not so much because those are still either in discussion or confidential. So what this street network model does is first, what it is actually, it's a spatial modeling used as a bottom-up approach to analyze street accessibility. And I'll explain more in the slides later. But at the end of the day, it's how we can use analysis to inform and value add the planning process in Singapore. So this is what the model looks like. The first thing it does is it measures accessibility of the existing and proposed master plan. Let me close this. Yeah, so for example, let's say we have different master plans from different stakeholders. We are able to measure, using this model, the before and after scenarios. So what is the impact? What is the impact of change before the existing and the proposed? If we say, okay, if the new master plan is going to be implemented, it's going to increase this accessibility of this street by how much? By 10%, by 15%. And these numbers are important because it's not just quantitative, but we are able to correlate that to land values. So this is why it's very important. The second one is not so direct, but it's to uncover any potentials in routes such as cycling routes, any pedestrian routes, and identify if there are any missed opportunities. So in a nutshell, what the model can do for us is for us to make very wise decisions so that we don't have to reconfigure the entire network because we don't want to change the whole, all the streets in Singapore. What we want to do is to just see whether we can add a single connection, a new street, or to pedestrianize a single street such that the impact, so we can attain maximum impact by minimal change. And sometimes we realize that we don't even have to do anything. What we can do is probably to widen the road, to improve the street qualities, to plant more trees, just to enhance and attract more people using the street. It's not all the time that we have to change, do a drastic change. So I'll bring you back to more about Space and Text Limited in London. It's a consultancy, but also a research lab. It started at 1970s at UCL, the Space and Text Lab. So these are where these tools were developed from. And today, the company in London, they have done many relevant things, such as they have they're not just a consultancy, but they also develop digital tools, such as the open mapping of the Great Britain, which is available online, and it's free for all to access. So it's a pre-processed spatial network model, and it's published online. So if I send the link later, you guys can have a look as well. But they also do things like a walkability index, urban value modeling, and also one called Citizen Explorer, which is a very interesting user interface tool where all the data sets are already incorporated. And it's a way for us planners to use it as a decision-making tool. Also, it's not just street network analysis, but you can see on the right side, this is an image of Harrods in London, which I'm sure many of you have been. We do visibility graph analysis and agent-based modeling to predict human movement. And this is better more for interior spaces, building scale, or even a small neighborhood scale. So not so much a very macro scale. On the left is our, so Harrods was one of the signature projects from Space and Text Limited. Also, one of the key projects was Trafalgar Square in London. And in the past, it was, not a very well-used or organized public space. So what was done was they analyzed pedestrian flow and activities to look at the existing situation before applying street network modeling analysis to it. So it was more about the correlation and validation between quantitative analysis and qualitative analysis. So wanted to show you guys all the different aspects of space in text. This is a model of Singapore. This is a space and text street network modeling. And this is something that CLC, us as a team, we built it from scratch ourselves. I mean, the Space and Text Limited in London, the office, they had a model of Singapore, which I had access to, but I couldn't use it because I left the company. And it was also, there were also like many errors. So I just thought that it would be just great for CLC to build our own model. So it took us 2 months, 2 or 3 months to build this model from scratch. And this is a single line model, which means that if the road has 4 lanes, we condense it into 1 line. And every, if there's a pedestrian lane beside a vehicular road, it's still 1 line. It's a single line connection model. And the main idea is to measure the spatial depth. So this is a global scale. And this might seem quite confusing for you guys now, but don't worry. So this is a global scale, that means the whole system. And the warm colors means, the warm colors red, that means high accessibility. And it goes down to the colder colors, blue, which is low accessibility. But you can see that, I guess there's the thing blocking the numbers there, but the radius of measure gets lower and lower, from 5,000 to 3,000 to 2,000 to 1,000 radius scale. So when the radius of the model gets lower and lower, you see different readings and very interesting readings. So I'll do it again. That's 800 meters. So 800 meters would point you the accessibility of smaller streets, of smaller neighborhoods. So you can see maybe like, maybe you can see my mouse, but the Little India area, the downtown area, it's going up. So the whole system one, this is the final one, it picks out the highways, the freeways, the main roads. And then as it goes slower, it picks out where the accessible roads in the neighborhoods are. And this is just based by graph theory, by geometry. This is not, so no other spatial urban data has been incorporated yet. The model is, how it works is that we do a baseline analysis, which means we just analyze intrinsic spatial qualities based on this model. And then at a later stage, we are able to add on other factors, other data. It could be population, it could be land use, could be any type of weighting, could be income level, house prices, anything that you have, as long as it can be pushed or attached onto the street network model or incorporated, then we can do more weightings or validation to see if there's any correlation. So this is just a static geometry model. The model is based on betweener centrality, the concept of it, and it's based on a graph theory of like shortest path. So I won't go into detail about this, but basically it measures from every point, every vertex of the model, every street, from every pair of vertex, what is the shortest path? And after the computer runs all the possible permutations in the model, the streets with the highest overlay of shortest path from every point to every point will be the highest accessibility. And also the weighting for this model will be angular change. It's based on the theory that people walk in straight lines. So if the street, from street to street, it's you're going in a more or less a straight line, then there'll be a higher factor towards accessibility. Whereas if you're required to turn a 90-degree turn like B or C, then it reduces the accessibility. So if you imagine this, the computer is measuring from every point to every point in the model. Then you imagine this model, and this is the East Coast area of Singapore. Then you can see that the red lines here are the ones that from every point to every point in the model, that's the highest overlay. How does that translate to urban planning? So what that means is that the highest overlay means the highest potential for human movement, for vehicular travel. Because just by geometry, just by the nature of geometry, even without putting MRTs or tourist attractions yet, just by a natural movement, that's what we use it. We use the word natural movement. Just by natural movement, there is already attraction to people using it, that path, because they have no choice. They just have to use it to get from point A to point B. So this is what the model is about. And here one more time, this is the global scale. And I would like you to take your eyes on Dunman Road. So Dunman Road on a global scale, it's not super accessible. It's like light orange, which means like a medium accessibility. But as the model goes into a more final detail, you can see it becomes more accessible. 2,000, 1,200. So what does this mean? So it means Dunman Road might not be very heavy, might not have so much potential to carry vehicular movement, but it might be a good place to have more pedestrianization, more smaller shops, more cafes, what have you. So these are the phenomena that that you can see when you make use of the model, because this model is multi-scalar. Yeah. And okay, now I've done explaining the model. Early this year, we had a chance to go to the SLA 3D Sandbox, and we managed to visualize our model using the SLA model, which was really interesting because, when you present to stakeholders and, it's very hard for them to visualize. But once you put, 3D models and then with our space syntax model, then it becomes more clear and more exciting. So the lighter the lines here are the highly accessible. Yeah, so that was a fun thing to do. And then we would like to work more on SLA to see how we can take this further. And then the other thing was with our collab with NSCC. So I've been running the analysis. Before I met Bernard, I was using my laptop to run this model, and it took me 4 or 5 days on my poor MacBook Pro to run the analysis. And it was just it's not as sustainable, because yes, I can do it one time, but it's going to kill my computer and kill myself. So NSCC reached out to us, Bernard and Tommy, to see how they can help us. So right now we are using GetMap X software, which is a free and open source software to run analysis. So all of you guys can also download it online. With their help, we were able to tap onto their NSCC server remotely, and then using the command line interface with the GetMap. So some work was done. It was not magic. There was work that had to be done, because GetMap X software was not a software that NSCC could recognize. But we got it done, and now the process is much smoother. So now NSCC can process the modeling for us, and I even get an email when the model's done. Yeah, so that was a life changer, and this is what it looks like. Yeah. So what are the benefits of a street network model as a baseline analysis? First is, before we meet any stakeholders or, other people from other agencies, we like to do some prelim studies first. So when we do overseas projects, like I was doing a project in Cyprus, and before I even went to Cyprus, to the capital of Nicosia, able to perform an analysis so that even before we go there, we already know what the town structure is like. So it's just easier for us to know more about the city through analysis. So the prelim studies is always good to make a case to other people. It also avoids guesswork between. I find that during meetings, sometimes there's many parties involved, but you think you're talking about the same thing, but actually you're talking about different things. So having a street network analysis or some kind of objective modeling or model will allow everybody to focus on the same page, be on the same page, focus on the same topic. But the best thing about the model is that you can test your ideas on it. So let's say you want to you want to change vehicular road into a pedestrianized road. You're able to test the model before and after. What is the impact of it? So before you actually make a decision, you can test your decision based on the model. So you can have an option 1, 2, 3, 4, 5, and the model and doing analysis can tell you which option will be the most viable one, or the most you can also put that to costing as well. Yeah, so I'm not sure how much time I have left. I have actually 3 demo studies. Maybe I'll just do one. And then, Angie, maybe you can let me also know how much.
We are a bit overrun by 5 minutes. Yeah.
Oh, so I have 5 minutes left?
No, overrun by 5 minutes already.
Oh, okay. Oops, sorry. Okay, so the first one I explained before is before and after impact. So the first one was our CLC project, the Sustainable Innovative District project. We wanted to measure the different master plans by the stakeholders. So the existing one, you can see, it was the NUS area, One North area, and then the proposed one. So for the existing one, we have the One North NUH Science Park. I want to bring your focus to the AYE, but you can point out yourself that blue line. So existing, right, the AYE is very poor accessibility. But with the new master plans for One North, so back and forth, from One North and NUS, the accessibility has increased because the One North and NUS, the master plan, they reworked in the proposal, the grids were more dense and they connected better across the different plots of land. So we're able to test this and feedback to the stakeholders, what is the impact like. And then this one was, everyone's talking about the 1 minute city, 20-minute city. The LTA master plan for 2040 was a 20-minute city. So that means they were trying to make it such that from your home to the amenities should be 20 minutes or less. So we as part of our demo, we were looking at different amenities in the East Coast GRC, and then plotting out the homes. So with all the polyclinics, parks, and then we tried to measure. Okay, from so all the points here are homes. 1 point is one plot of one residential plot. So if we mapped out all the different amenities against the distance, and we found out that the red line here is a 20-minute mark. So that means that there are many homes outside the 20-minute mark to any of the closest amenity. So in order to do that, what can we do? Should we bring the amenities? Should we build more amenities in the homes, or are there any clever ways we can do that? So this is how space and text help us. So we mapped out the cycling path from the proposed cycling path, and then we looked at the model. There's a thing where we did a recommended cycling routes, so we can see how the recommended cycling routes matches or don't match the proposed cycling routes, and also how can they lead to the amenities. So instead of building new amenities, can cycling routes proposed or what we recommended, can cycling routes help accelerate and break down this barrier between homes and amenities? And how we don't necessarily have to build new amenities all the time. So these are the way that we can use street network analysis to look at mobility issues. And the end with this is also CLC, we provide training as well to other agencies. One of them we did earlier this year is to the URA urban designers and architects in their IEM project, the Analytical Immersion Program. And what they wanted to do was to test different tools. So space and text came as an exploration on how we can use spatial analysis to analyze public spaces and evaluate what makes a good public space. So these are the types of collaborations we can do. And I hope that CLC, we can also reach out to other agencies to see how we can collaborate. Another one that I'm really proud of is our new collaboration. It's still in discussion in a moment with NEA and MSc, and also with the Ngee School of Design as well. And we are trying to see how we can evaluate and redesign using spatial analysis the future hawker centers of Singapore. So hawker centers and wet markets in all scales, from building to urban scale, the urban network scale, because we want to know how hawker centers are placed within Singapore's network, and how if we want to locate a new hawker center in the future, how can we do that effectively? So we are working right now with NEA, and we are going to use agent-based modeling and visibility graph analysis to look at the spatial layout of hawker center and evaluate the system, the space as a system, and see how it can be improved. So thank you. Sorry, I overran.
Thank you so much, Genevieve. Right. So right now, I'm just going to invite Song Yu to join us.
Thanks, Angie. Okay, let me share my screen first.
Okay, all you may know him. Song Yu is the executive data scientist from the Design and Planning Lab from URA. Thank you, Song Yu.
Good afternoon, everyone. I'm Song Yu from URA Design and Planning Lab. So for today, I'll be sharing more on how actually URA uses network analysis, one of the many techniques in planning. I'll just quickly start off with a quick intro, followed by a few use cases on the application, and lastly, just to sum up some of the key points. So URA is the Singapore National Land Use Planning Authority. And our mission is to make Singapore a great city to live, work, and play. Hence, actually, a lot of our work are usually map-based and GIS-related. And network analysis is quite commonly used to better understand the accessibility in our home and different amenities. So our main challenge is how are we able to cater all the different types of land users in the limited land space that Singapore has. So unlike many other cities, we cater for the needs of both a city and a country. So that means our land is not just for housing, commercial, industrial recreation. We actually also need to plan for national needs like ports, airports, military training ground, or even defense space, which is usually outside city area in other countries. So we also work very closely with other planning agencies like HDB for housing as well as LTA for transport. Our planning approach has been centered on 3 key pillars for sustainable development, so economic, social, and environment. And the objective is to really optimize this within our limited land and sea space. Recently, we also plan for greater flexibility for change of plans as well as resilience to be prepared for challenges such as climate change or even like disruptive events such as COVID, or even including technologies like Grab that change how people move in Singapore. So URA adopted this planning framework since the 1970s. So usually we will start off with a longer plan, previously known as a concept plan, now as known as the long-term plan, to actually plan ahead. So we actually look out for broad users in the spaces of broad users across Singapore, and looking plans beyond the 15 years. And with that as a guide, we will then translate it to a more detailed master plan to guide developments for the next 10 to 15 years. So at the detailed master plan, we actually look into the individual parcel level to decide what is the type of land use or the type of amenities to build in the different house. So this includes sightings of new amenities such as polyclinics. And subsequently, the plans are actually reviewed every 5 years. So to better illustrate how network analysis has been applied in urban planning, I will share in terms of 3 main key users. So the first one is coverage and gap analysis. So what happened is we have actually improved in terms of using the GIS technology. So in the past, we have depended quite a bit this thing called the Euclidean buffer, which is the straight line buffer. But straight line buffer might not be the best accuracy where infrastructure plays a very big role. So for example, in this green polygon, which is a park, in the Euclidean buffer, it shows that it's also near to the residents at the, let's say, the bottom left. But after looking at the actual infrastructure, which is your walking network, or even like the overhead bridges and more, we find that due to the lack of infrastructure to get across, the actual buffer now, which is the dark brown polygon, is the actual coverage of this particular park. So this is ready to help us improve our understanding, the use of a more granular data eventually. And it will eventually also help us to plan for all different types of groups, as well as including like elderlies or people with disabilities. And the base information that is really required is the walking network, or the walking and cycling network itself. So we have been starting to build up this data set, which I will share a bit more later. But this really captures the attributes or characteristics of the pathways that's around Singapore. So things like whether it is sheltered, non-sheltered, air conditioned, or is it a cycling path or a park connector, and so on and so forth. So just a quick example with the walking network, we are now trying to go beyond what is used in the past. So for example, in this walking network, I specifically highlighted which paths are actually the non-barrier free path. So for example, staircase, for example, curbs. These are highlighted in red. So if I want to know from a particular block to the, let's say, the Bukit Batok Polyclinic, what is the best route possible? This is usually done by looking at the shortest distance. So over here, you will then see that the light green path demonstrate you can actually take across the route, go up, let's say, a staircase, and under the void decks before you reach the polyclinic. So how about people who are on wheelchair? So with the information that's collected, and now it's really possible to find barrier-free access routes instead. So you will see then the barrier-free access route is actually doing a bit of detour or a extended path where wheelchair can actually pass through. Then this leads to the next section on whether should we build more alternative to reduce the distance on. So with that as the fundamental, then we can study things like coverage and gaps. So in terms of coverage, we can ask questions like, if I build a certain amenity in a location within a 400-meter buffer, where is my catchment like? So this will then better understand where are your potential customer or people coming from. If we then look into the barrier-free access, this is where we can also look into a gap in terms of catchment. So the reduction in catchment due to the barrier-free is a way of indication that there is a lack of, let's say, the alternative, the barrier-free access to this particular location. Hence, planners can then drill down in these locations to see where best to place some of the ramps, etc., as alternative, so that we can increase the coverage again in this area. However, I would say that actually network analysis is quite technique that is actually used for many years, but rather is the input data that is lacking as of now. So what you have done is actually to start this initiative to allow people to help to volunteer and help and update the walking network through a mobile app. So currently we are using this app called the ArcGIS FieldMaps that have access to the walking network data. So this is just a quick video on the UI. So you can actually add lines, delete lines, update lines, and attributes accordingly. And it's actually open to all volunteers. So if you're interested, you can also come in to support in this crowdsourcing effort. So you can scan this QR code. I will share this QR code again later at the end of the slides presentation. So after building the walking network, of course, then we want to look into how best to plan for amenity. So how do we right-side some of the amenities to the different home? So if with aligned with LTA, Land Transport Master Plan, so one of the key things is the 20 minutes count, where every 9 in 10 households should eventually be in 20 minutes away from the amenities. So to improve this, there's actually two ways. Of course, first way is to plan the amenities near the home, or secondly is to improve the infrastructure. So today I will focus more on how we then right-side the location of the new amenities and going beyond the walking network itself. So on top of the walking network, then we actually added on the lines or the services, routes, things like the bus or the trains, eventually adding on together the transfer points with the walking network to create the full public transport as well as the walking network as a single network to use for analysis. So with this combined network, this is where we can also analyze coverage and get analysis of the 20 minutes town. Yeah, so this is a screenshot of, let's say I have all the blue dots as the amenity location. The green polygons are the location of the 20 minutes coverage, how far they can reach to the amenity within 20 minutes. Also the population count. So we also look at where are the population living as well. So the benefit of this is eventually we can do some scenario testing. So we could do like plan A with the location of all the blue dots, applying the public transport model to see where is the 20 minutes coverage and looking at where are the gaps. Of course, then compare with another plan, with another set of amenities location with some changes along the way. So you will then see different type of results where you can further dive in to then calculate what is the difference. So this is just a way to calculate trade-off. I think eventually, I don't think there's a perfect plan that is always benefiting everyone in Singapore. So this is where understanding the trade-off is critical so that we know who are actually benefiting from plans and who are actually the worst off in the plan, where then planners have to then look into the details and make the best decision out of it. Yeah, so in this case, what it meant is that those in the darker orange has a lot more public transport travel time savings compared to those in the blue ones. So plan A, this region will be benefiting. In plan B, this region will be benefiting. Yeah. So this is how we try to look into the trade-off of the different solutions. And we have started to also look into how do we then couple with other type of modeling such as optimization modeling. So this is just one example where we are looking at, given currently 2 locations of the amenities and the demand around it, and looking into constraints such as we wanted to reduce traveling time, and we also want to ensure a good balance between the demand and supply of the amenity. We can then recommend, let's say, new locations of the amenity and maybe the proposed boundary that the amenities should cover. Yeah. By automating such of the recommendation, actually planners also have more time to look at the more qualitative assessments such as cultural and heritage in the location, which is also very critical. Okay, in the last use case, I will share a bit more on how we look into planning of infrastructure. Yeah, and in particular, we focus more on the walk and cycle part. So on top of just the network itself, we also try to look into other data sets. For example, the EasyLink data set, the tap in and tap out. What we quickly realized is about 40% of the trips are actually less than 2 kilometers from point to point. So we are actually wondering potentially is cycling a viable alternative because some bus routes are planned to go a detour. So perhaps cycling could be a more direct alternative and save some of the travel time. So we started trying to analyze the EasyLink data to see how we can maybe come up with insights on where to build a cycling path. So just to illustrate between with and without the network analysis. So on the left, you can see a lot of lines, and the one in red are the one with the higher number of public transport tags. That means a lot more people travel from this point to this point. But it's confusing because we really don't know where are the routes that is affected. So when we apply network analysis to find the shortest cycling route, and also maybe have a very simple model to simulate complexity to cycle. That means the shorter the distance, the higher the chance a person will cycle. We then calculate the combined demand on the actual infrastructure. So one key thing I think I can highlight over here is that if you look at this area in the north, there is no direct red line because this is all point-to-point demand. However, due to the infrastructure, which is limited, the demand actually have to cross the same path, which is the inter-town path over here, hence highlighting this compounded demand. Yeah. That's why we actually look into using network analysis to have a more concrete insight on potentially where are the high demands for cycling. Yeah. So we can see intra-town demands as well as inter-town demands in this case. Other than just the point-to-point commute, IEMSIM also can tell us the transfer point. So for example, you take a bus to a train station and then you switch to a train station, or even between two bus services. So in between them are also known as the transfer point. So when we look at major transport node, especially your interchange as well as your train station, we can similarly also see the straight line demand from point to point at every 10 minutes over here. When we apply the network analysis in a similar way, we can study the density flow and highlight which paths are potentially having very high density, and there's a need to widen the path. So this indicator, known as the pedestrian flow rate, was actually taken with reference from the Transport for London that they used in their planning. Yeah, so we tried to apply in Singapore context, and we actually found this path is really high density, which is really your interchange to your MRT station. And what was done later is combined with ground observation. This was actually brought the stakeholders to actually request to remove the pushcart stop that was used to be there. By removing them, you will see actually it's a lot more spacious, hence improving the pedestrian comfort. Yeah, so in the third use case, it's ready to look into how we might want to plan for a cycling path and also maybe to improve pedestrian comfort. Finding some of these areas. Yeah, so to sum up, network analysis actually really help us analyze more granular and accurate locations, and to understand how we can improve the way people travel on the ground of different travel routes. And we also try to couple with various modeling to analysis and insights. But we will still think that methodologies is only one aspect. The key fundamental will still be the walking and cycling network. So once again, I just want to invite anyone who likes to volunteer and scan the QR code over here and let us know. We will actually follow up with you on the next steps. Yeah. And eventually, the use of the network data set, right, is definitely we hope to move towards the public and industry for greater benefit. Yeah. So these are actually also useful for example, like things like Grab, as well as when the public want to find therapy access. So this will be the eventual end. Yeah. So that concludes my presentation. Okay, thank you for your time.
All right, thank you, Song Yu, for this very interesting topic. We have quite several questions. Before that, my apologies that we have overrun by 3 minutes, and probably if you all don't mind, do allow me to take another 5 to 10 minutes of your time to answer some of these questions. All right, so I think one quick summary of what the speakers have said is that there are already very good use cases and proven modeling platforms is available to all of you, including HPC supercomputing platform that you can leverage on. So one of the questions that was asked was, how can I leverage on it, and especially when we don't have the scientific talent nor the model? So the answer to it is very simple. Do reach out to us, Angie, myself, or even the speakers. NSCC works with a lot of researchers from NUS, NTU, SUTD, URA to and many other researchers itself. We can connect you to the right researcher who has used the platform, who has the model, so you don't need to reinvent the wheel. And today, learning from Genevieve, I learned that HPC supercomputing also helped her to elevate her pain point in the mental distress that she has to work on her laptop. So now I realize that supercomputing can relieve mental pressure. So that's one thing good. Thank you so much for that, Genevieve. So I just want to quickly give some time to the audience. I'd like to invite Angela Lau. I believe you have a question, Angela. You want to unmute yourself? Angela, are you there? Angela? No? Okay, if not, let me ask the other question that is, first off is for Genevieve. Ronnie is asking, if you combine the pedestrian path along the roads to a single line, how do you use your analysis the way you mentioned at Diamond Road? How do you analyze usage for vehicles or pedestrian when data are merged?
Yeah, this is actually I roughly saw the questions. I think all these are very common. It's a very good question. With the street network model, I think I didn't mention that we actually work with a few models. So first was the model I showed you, which is a single line model. We have a model from SLA, which is a vehicular model. So no pedestrian path, just vehicular only. And then I have a model from UIA from Songyu, which is a pedestrian model, but it's not completed yet. So the pedestrian model doesn't have the expressways or highway. And then there's a model that we created, which is the all access model. So both vehicular and pedestrian, which we found is the most effective because essentially we are trying to measure spatial depth, which means the relationship from point to point and the relationship of the street, the properties of the street in relationship to all the other streets in Singapore. So for example, Orchard Road is accessible because it's considered accessible because it's more accessible than the road beside it or the road 2 streets away. It's all about the relations, the relationship. So that's why it's sufficient as a baseline analysis to use a single line model. In fact, it's more accurate because this is a network analysis. The more lines you put into it, then it will complicate the model. So as a first cut, we always use single line. And then in the future, if let's say we want to do more micro scale analysis, then a pedestrian model will be very useful. So in a few years, when the model that Songyu is working on is ready, we'll have a really good, we can use that model to process it again. Yeah,
right. So don't worry, with supercomputer, you don't need to wait a few years. Okay, Songyu, the next question is for you. Do you have a plan to have a 3D walking path? Do you distinguish between overhead bridge slope gradient, for example?
Yeah, so the current version is still 2D because that's the, okay, there's a limitation of the app that is still collecting data in 2D. But we actually use attributes to distinguish between the bridges, the underpass, and the high-grade section part, which is the ground level. So it's still possible to add those network for analysis as of now. But of course, we are actually looking into some possible plans to then convert the existing data into 3D. That will actually simplify some of the things that we need to collect as of now. Yeah.
Okay. Okay, the next question is for Dr. Luo Ching. Do you have plans to incorporate weather climate data into your IEM Sim? And if so, when?
Yes, for IEM Sim, in fact, we already, for IEM Phase 2 project, we work with CCRS already, and CCRS is a collaborator. So we're incorporate their model automatically and into the IEM Phase 2. And also another part is we're collecting all the NEA weather station, and they will retrieve all the weather station data and do the data simulation and also extract the information to drive IEM. Yes, we already working on it.
Thank you. Next question for Genevieve again. Is the street network based on human or vehicular traffic? Since it's only one line, how about path and network for cyclists? Singapore doesn't have distinct path for pedestrian, cycling, and vehicle due to space constraint. It is rather dangerous, especially in a neighborhood with pedestrian walkway sandwiched between cycling and road. Can the model distinguish and yet optimize the layout of this three paths? And how does it translate into actionable infrastructure for Singapore?
Yeah, so the first one, the first part of the question, I believe I answered it already. The second part.
How do you distinguish with a constraint and distinguish these three particular traffic: human, cycling, and road? You know.
Yeah, I mean, in the model, we have different models to answer different things. So depending on what we want to find out, we use that model. For example, if we want to use a vehicular model or the all-access model. I'm trying to see where you're coming from this question. The model doesn't optimize the layout of the tree path. It's more like it gives us insight as a baseline analysis, and then it points us to the different give us different insights on where we can zoom into.
Maybe we can unmute Esther, and Esther could further elaborate on her question. Esther, are you there, Esther? No?
Hi.
Hi, Esther. Hi.
Hi, Bernard. Hi, Genevieve. Yeah, actually, I've noticed at certain neighborhoods, especially in the east, where the walking path is actually in the middle of the road. So you have the road at one side, and on the other side is the cycling path. Yeah, so actually the concern is if you have different models to model the three distinctively, I mean, you can get the optimal network for each of them, but the three still relate to each other. I mean, these three, can we say actors? Yeah, so these three different groups of people will still need to live together in a sense. So in terms of my concern, it would be the pedestrians which are sandwiched between the cycling path as well as the road.
Okay, because you feel like it's since they are at such close proximity.
Yes. And the cycling path and the pedestrian path is just next to each other. Besides the lane markings, there's really nothing else to stop one from going into the other path, and then you have accidents happening.
Yeah. I see you. Now I see where you're coming from. So it's more like it's more like if you are the user of the space, like is there safety issues, the comfort issue?
Yes, safety. I've seen in your presentations and the presentations of the other panelists, like you have convenience, you have distance to each amenities. I mean, that's great, but in terms of path, these three people will need to interact with each other, and that's where the risk and the danger, or rather the security comes in.
Yeah, I think that's a very very relevant question to Singapore. I mean, the model cannot answer that. The model can tell you only like which streets are accessible and which streets are not, and they can make certain recommendations. I mean, I can let you know that also currently we're also, there's a repurposing of roads at different parts of Singapore. From LTA, they are trying this thing where they are repurposing one of the lanes of a main road to try to see if it works as a cycling path. So I think this is where the agencies can come together to see how, like network modeling, because we only give the baseline analysis, but how this can maybe the network model can give off certain red flags or point out where the bottlenecks could be. And I believe that also going back to Song Yu's model on the walking network analysis, when the one more elements are incorporated. So maybe that would be a better fit. But I think you raised a very valid point. Like after like all this modeling, at the end of the day, like how do we bring these models and the findings into real on the ground urban design, urban because at the end of the day, we're walking on the streets. The model has nothing to do with it anymore. We're the one experiencing the street. Yeah, I would love to know. Actually, I would love to also work more with URA and LTA on this.
Okay. I think we overran by 15 minutes. I think that's very exciting discussion, and please don't stop here. Feel free to email to ask your question or your interest to connect with the speakers or to find a scientist or a consultant for the particular role that project you're working on. We will be more than happy to connect with you and help you in your project. Ultimately, whatever we are creating will be the benefit of Singapore as a country and for all our Singaporeans in a more livable city. With that, I would like to thank the panelists, and I'd like to thank GeoWorks and SLA for co-hosting this. And I think this is very exciting. Do look out for more, especially the Geospatial Innovation Challenge that we are about to announce soon. I wish all of you a good afternoon, and please stay safe, keep healthy, and we will speak again, definitely. Thank you, everyone.
Thank you.
Thank you.
Thank you, everyone. So we have posted the link to the post-event survey. Do help us by filling up to let us know where we can improve and what you like, or if there's any questions or you want us to link you with any of speakers, you can fill in your comments via the survey as well.
All right. Thank you, everyone. See you.
Thanks. Bye-bye.
Bye.
Bye.